The question number 16 is a rocket having fuel as its bulk is initially at rest, neglecting the effect of gravity when the fuel is burning at a constant rate. Acceleration A of a rocket with respect to time is best represented by one of the graphs. Now, dear students, what happens? This is the rocket and the fuel is coming out with certain exhaust speed and a rocket is experiencing upward force. Now, what is the upward force on the rocket? That is exhaust speed into the rate at which the fuel is burned, which is constant. That means the force on the rocket is constant and the force on the rocket is the mass of the rocket into the acceleration. Now see, as the time passes, the mass of the rocket decreases. Let's say at the launching pad, it has mass m0. Now, this is the rate at which the fuel is burned, dm by dt. Let's say write as alpha, which is constant, into time, multiplied by the acceleration. Now, what they're getting? That acceleration is equal to F divided by m0 minus alpha into t. Now, as time increases, this factor reduces and acceleration increases. And at time 0, it has certain acceleration f upon m0. Look at the graphs 1, 2, 3, and 4. In the fourth graph, what do you find? It has certain value of acceleration. As mass is decreasing, it's increasing at the fast rate. So therefore, the correct option is the option number 4 to this question. The question number 17 is when a force of 6 Newton is exerted at 30 degree to a range at a distance of 10 centimeter from the unit as shown, it's just able to loosen it. What force is required to loosen it if applied 15 centimeter away to the range and normal to the range? Now, dear student, what is saying that this was the diagram, and from here at distance of 10 centimeter, a force is exerting like this one, and this force is of 6 Newton, and this angle is given 30 degree. Now, instead of this one, this will give the torque, and how much torque it will create? We can write here torque is equal to the force. So we'll take the lever arm as 10, and the force will be the component in this direction. That is 6 sine of 30 degree. Therefore, the torque become 0.1 is the distance, and torque is 6 sine of 30. The one equation. Now, he says that in order to get the same torque, what should be the force exerted at this end, which is at 15 centimeter from here, and the force should be applied normal to this to get the same torque. Therefore, the second torque will be the F multiplied by the distance from the rotational axis, this point, that is equal to 0.15 meter. So F into 0.15 has to be equal to 0.1 into 6 sine of 30. And you know that sine 30 is equal to half. So 6 by 2. So solve, we get F equal to 2 Newton. Therefore, the correct option is answer 2 to this question. The question number 18 is a bicycle comes to a skidding stop in 10 meter. During this process, the force on the bicycle due to road is 200 Newton and is directly opposed to the motion. The work done by the cycle on the road. Now see, if you take the wheel of the cycle, then this was moving in forward direction. Therefore, the friction force on this wheel is in the backward direction to give it stop, and this is exerting the same force on the ground, but there is no movement for the ground. So as the displacement for the ground is 0, the work done on the ground by this frictional force will be 0. Therefore, the correct option is the second one. Now, the question number 19 is a car weighs 1800 kg. The distance between its front and the back axle is 1.8 meter. Its center of gravity is 1.05 meter behind the front axle. The force exerted by the level ground on each front wheel. Now, dear student, what is there? If you look, this was the vehicle, and he says that these are front wheel 1, 2, so back, and this is the top view, and the center of gravity is here. From here, it is at the distance of 1.05 meter. So, in rear wheel is at the distance of 0.75 meter from here. Now, let's look at the side view. This is the front wheel, and on the two front wheels, the normal reaction is say R1. The center of gravity is acting at this point, which is equal to 1800 into G, and this distance is given 1.05 meter, and the reaction from the ground on the rear wheel is say R2, and this distance is given 0.75 because 1.8 minus 1.05 is this one. Now we want to find out what is R1, the front wheel. Now, one equation you can write that R1 plus R2 is equal to the weight, but that won't be sufficient. So we have to go for the torque, and let's take the torque about this point. You can take the torque about any point because it is under equilibrium. Now we take the torque about the point, this point R2. So the torque of one weight and second reaction, this R2 will have no torque. So torque about this point, I am taking the rear wheel, then the torque will be 1800 G is the force, and the distance from here is 0.75, and sign is minus because the clockwise are taking negative, and now the torque because of this, that is equal to R1, and distance is 1.8. Now this should be 0. So 1800 into 9.8 into 0.75 is equal to 1.8 into R1. Let's solve for R1. So R1 comes to be 7350 Newton. Now see, this is distributed equally on both the front wheel. So on one wheel, the reaction force will be equal to, that is 7350 divided by 2, and that gives 3675 Newton is the correct option. And see, the option 2 is 3675. So the answer is 2. The question number 20 is a 17 kg astronaut is repairing spaceship at a height of 640 km above the surface of Earth. His weight at that location is nearly. Now see, his weight on the ground is given 70 into G. Now we want to find the weight at the height. We know that the gravity at the height is equal to G and R over R plus H whole square. So the apparent weight multiplied by the mass, so that is equal to, so this we want to find out, and this mg is given 70 G, and what is R? 6400 kilometer, you can take as such 6400 plus the height is given 640 and whole square. So when you solve this, so 70G multiplied by this, and you get the option of 580 Newton. So the correct option is 3 to this question.